welcome back, everyone. I hope you all are enjoying lunch and had great conversations and meeting new faces. As we mentioned earlier, it's now time to dive in the hotly anticipated nuclear panel that Mr. Curtis alluded to. So please welcome Nick Loris from C3 Solutions. He's the Vice President of Public Policy, and he'll introduce the rest of our panel.
Great. Thank you, Evan, and thank you to the CREST team for another wonderful National Clean Energy Week. It's been great so far. We'll keep this panel definitely hot, a little radioactive, but not too radioactive. I'm really excited to be here. For those of you who don't know about C3 Solutions, that stands for the Conservative Coalition for Climate Solutions. And we're a relatively newish think tank based here in DC that focuses on free market solutions, really centered around energy, the environment, and climate progress. And so we are very resource neutral, technology neutral, based around solutions for public policy standpoints for energy affordability, energy reliability, and environmental progress. And nuclear is certainly one of our policy priorities, so I'm super excited to be moderating this panel with my esteemed colleagues here. And so to start off, rather than kind of run through the biographies, because that would probably take half the time, I'm going to run down the line and have you all introduce yourselves, your organizations, and tell us a little bit about what you're most excited about with regard to the nuclear sector. There's been a lot of great announcements within the past week that we could talk about, let alone the past year or so. David, we'll start with you and move down the line.
Great, thanks. And thanks for the opportunity to be here. I'm David Brown with Constellation Energy. We are the largest owner and operator of nuclear reactors in the country. We've got 21, soon to be 22 reactors in 4 states, and then we're part owners of another 4 units. So I think the thing that excites me the most is the growing bipartisan support for nuclear as a climate solution. We have been on quite a streak here in the last few years on the Hill and elsewhere in the states as well. So just it's an exciting time to be here and a lot of momentum to capitalize on.
Hi, everyone. My name's Marcie Haber. I work for Oklo. We are an advanced fission and nuclear fuel recycling company. And what we will be doing is selling electricity to our customers through power purchase agreements. We are building small, fast reactors. And our first one will be deployed in Idaho at Idaho National Lab. We also have a few other deployments announced with various customers from data centers, oil and gas, and other heavy industrial users. I think what I would say I'm most excited about, or the biggest opportunity that I see right now, is the support and progress on fuel recycling, both on research and development, both on policy developments. ARPA-E with DOE has been doing a lot of research and development at Argonne National Lab. INL right now is recycling fuel that Oklo is going to use in our first reactor at INL. And just this week, Senators Cruz and Senators Heinrich introduced a bill, a recycling study bill, so the support is there from Congress, and we're really excited to see that.
Hi, I'm Kati Austgen. I work for the Nuclear Energy Institute. We are the policy association that represents all of the nuclear energy industry. So I'm here with several of my members today. We do have owners and operators of the current fleet, designers of the future fleet, those in the supply chain, those that are doing research and development, whether it's at national labs or even universities. So we have a very broad membership base supporting over 45% of clean electricity generation in the US comes from nuclear energy. So very excited about that. I will say another thing that I'm excited about for nuclear right now is not only our bipartisan support in Congress, but across the country with the public, across age demographics. All the polls say that they want more nuclear. And so we're here to help make that a reality.
Awesome. Brad?
Hi, I'm Brad Williams, policy advisor from the Idaho National Lab. INL is the nation's lead nuclear energy lab. It is the primary source of funding and programs to support the research, development, demonstration, and ultimately deployment of advanced nuclear technologies. We also help sustain the existing fleet. INL was established to test and demonstrate reactors 75 years ago, and close to 60, over 50 have been demonstrated and deployed in Idaho since then, and we're looking forward. There's several more on the way in the next coming years. Everybody took my answer for the bipartisan support, so I'm not going to say that, but that's clearly important.
New customers.
Yeah. No, so what I'm actually going to say is, and I apologize if I'm misremembering, David, but 5, 6, 7, 8 years ago, I was at DOE trying to figure out how to keep plants from prematurely retiring. And, several had announced it, and I worked with David and many others to figure out how to solve that problem. Thankfully, we did. Also, the growing energy demand has contributed to that. Thank you, hyperscalers. But back then, I remember asking, is it possible to restart any of these reactors? And I was told no. So what I'm most excited about is the fact that we have 2 and possibly a third recently retired reactor coming back online in the near term.
Great tee up for my next question for David. I mean, talk about the blockbuster deal with Microsoft. How did this all come together? What can we expect? And do you see more of this as potentially a viable solution for bringing some power plants back online and also upgrading some of our existing fleet to be cost competitive?
Yeah, absolutely. As Brad said, we went through this slump where we closed a dozen commercial nuclear power plants in the U.S., and those emissions in those areas all went up as a result because they were replaced with emitting resources. And TMI was one of those, and it was actually 5 years ago last Friday that we turned off that plant. While that site is remembered as the site of the worst accident in U.S. history, the other reactor at that site was one of the best performing reactors in the world. It had set a number of world records for breaker-to-breaker runs. At one point, it ran almost 750 days without stopping. And so it was a shame to have to close that plant for economic reasons. Fast forward 5 years, you've got excessive demand for electricity on the horizon. You've got IRA tax credits in place to incentivize new build and existing nuclear. And in our conversations with Microsoft, they needed a big, clean, 24/7 hour power resource to support their data center build out. And we've got a few partnerships with Microsoft around 24/7 power. And it's been great, but this was obviously the big deal. It will put 835 megawatts of generation back on the grid. It's a 20-year PPA. We will invest $1.6 billion in that plant to get it restarted. Overall, a report from the Brattle Group estimates that it'll pay around $3 million in state and local taxes and generate $16 billion in GDP for the region during its operation. As part of this agreement, the other important thing is that we agreed to relicense the plant, which will mean that it can run until 2054. So it'll be a source of 3,400 jobs to recover the plant and then 600 permanent jobs to get that going. So very excited about the opportunity to get that plant back up and running. We're also changing the name, naming it for Chris Crane, former CEO, who was instrumental in revitalizing the nuclear industry, and a great tribute to him. So very excited about that.
Yeah, that's great. And I mean, just thinking, you said it's the worst accident, and it's an accident that had 0 deaths, 0 accidents, 0 adverse public health effects. speaking to the remarkable safety record of the nuclear industry that we have here in the United States. And Katie, I want to jump to you next and kind of table set for what I'm going to ask Marcie and Brad. But can you talk about, given your experience at NEI, the advancements in different reactor technologies that we're seeing now?
Sure. So, as was noted, our current fleet has a very long and excellent history of operating reliably, operating safely, 24/7. We expect to keep that going with new reactor technologies, and as the nuclear industry has always done, incorporate lessons learned so that we can further enhance safety, we can further enhance reliability, we can make sure that as we see lots and lots of renewables coming onto the grid, we can complement those and operate our plants in a way that really strengthens the entire system. One of the things that I really look forward to is that while we're all familiar with nuclear energy as a baseload source of power, providing thousands of megawatts electric onto the grid, these new reactor designs are offered in a variety of sizes and a variety of technologies, which means you can add for incremental load growth, you can add for remote applications or microgrid uses. If you really need heat, not electricity, you can select a reactor design technology that will provide you with that heat, either a medium temperature or a very high temperature. So it's really an exciting time to think about the future of nuclear.
Absolutely. And Marcie, obviously, you're being at the forefront of one of those advanced reactor technologies. Can you talk a little bit about, one, your relationship with INL, the memorandum of agreement that was recently announced, and also kind of what you see for the prospects of the company in terms of getting more reactors online over the next couple X amount of years?
Yeah, so the agreement that Nick is referring to, yesterday we announced a memorandum of agreement with INL to begin site investigation work at our preferred site at the lab. So that is the location for our first deployment. This is a step forward, a needed step forward to get us towards construction. It's a parallel step right now. We're also working on our formal application to the NRC, and we'll be moving into the readiness assessment, ideally later this year. So we're in really good shape. I mean, right now at the INL site, we have a site use permit from the Department of Energy. We have 5 metric tons of awarded fuel out there that I mentioned earlier that INL is reprocessing for us right now. And now we're beginning the site investigations work out there. So we're really looking forward. I mean, of course we are. It's going to be our first deployment, but this is just one of many. Oklo's plan is to build dozens of these and eventually get up to hundreds, and we have a plan to scale in size. Our first plant is a 15 megawatt electric. We do have intentions to build a 50 and likely even larger sizes as well. What was the second half of the question? I got lost.
That was plenty. I mean, we could stop there because I want to shift towards public policy in a second, but I want to bring Brad into the conversation because you guys had an exciting announcement with the Pele project in recent days too. So can you talk about what Pele is, and also just from a broader perspective, how INL works from an R&D standpoint, but also working with companies like Oklo, as well as working with other agencies like DoD.
So yeah, thank you. We're doing a lot with a lot of different customers, including Oklo and others. Project Pele, I think, is a really interesting one and an example of new customers and new applications for advanced nuclear energy. So Project Pele is a Defense Department project out of their Strategic Capabilities Office, looking at deploying a transportable microreactor for forward operating bases. This may be known to you, but it blew my mind that the majority of military casualties are actually from fuel transport. And this is the trucks that are getting taken out on the roads. So Project Pele the intent is to provide that necessary power to bases with nuclear so that we can save lives. To me, that's really important. So I think there couldn't be a better project that we have ongoing. But what it's going to demonstrate is a very small scale, basically black box reactor that, you can move to where you need to. You can stick it on a plane and ship it. You can stick it on an 18-wheeler and drive it. Could be used for FEMA, for disaster recovery applications. Imagine if Florida had that, next week. That would be pretty impactful. So it's a really important project. It's really driving innovation in nuclear technology, and I think 2026, 2027 is when it'll be online and demonstrated and then ultimately used by the military.
That's really exciting. And in your relationships with companies, has that gotten easier over the years, especially with kind of a different mandate from the Department of Energy, more focuses on applied R&D as well as some of these demonstration programs like the Advanced Reactor Demonstration Program? How has that shifted INL's relationship with the industry? Or has it not? It's just given more resources?
It's shifted a little bit, but I think primarily it's expanded our role and provided more opportunities, more resources to really focus our efforts to meet tangible targets and true needs. And it really started, talking about the bipartisan support. There's been a number of bills over the years, but it really started with what was called NECA back in the 2017-18 timeframe that established the National Reactor Innovation Center, NRIC, to be led at INL. And that's really creating the test bed, the demonstration platform for companies to come in, partner directly with the lab, and demonstrate their technologies, on the small scale, but then also eventually full-scale demonstrations. So that's been driving it. And then actually, somewhat coincidentally, at the same time, the Department of Energy was creating a partner program that had a very similar goal called the Gateway for Accelerated Innovation in Nuclear. So now both programs are moving forward with slightly different focuses, but the goal was really to enhance collaboration between industry and DOE and the labs.
That's great. And shifting towards public policy, obviously one of the most significant wins from an energy perspective this year has been the passage of the ADVANCE Act. So this is a bit of an open-ended question. Any of you can take it, but maybe we'll start with you, David. But how do you see the ADVANCE Act helping the existing fleet of nuclear reactors that we have today? But then also, Kati, Marcie, jump in. How do you see it helping newer light water, larger reactor technologies and some of the advanced reactor technologies too?
Sure. So I think there are kind of three buckets that we look at on the existing side. Restarts that we talked about, 2 have been announced. There's maybe one other candidate out there that could restart. Uprates, where you can actually upgrade your existing plant, change out some equipment, and get more megawatts out of that very same plant. So our CEO has said we think we have about 1,200 megawatts that we could do to add to the grid, brand new. I think NEI has said they think industry-wide that's probably in the 2,500 megawatt range, so roughly the equivalent of bringing on 2 new plants just through uprates. And then the third is subsequent license renewals. Nuclear plants are originally licensed for 40 years, and then they can get 20-year life extensions. So most of the current fleet is running to 60. A couple of units have been approved to go to 80, and there's even some talk about possibly going to 100 years. And the NRC process is crucial to that. So the ADVANCE Act really helps by streamlining that process, trying to make it easier, simpler, more risk-informed, and by eliminating duplication that's out there. It also encourages the NRC to incorporate AI in some of their review process. So I think it really sets the stage for some great improvements. The NRC put out a report recently where they've identified about 30 action items coming out of the ADVANCE Act, And the fact that they've identified those means that we can track them, that they're measurable, and the congressional oversight can make sure that they deliver on that promise.
Go ahead, Marcie.
Yeah, one of the things that I think will be very impactful for Oklo and for other advanced reactor companies as they're working through the pre-application and application process at the NRC was a provision in the bill that's going to help reduce fees and change the framework for that a little bit. And I'm sure some of you know this, but the NRC is primarily funded by industry and not from the taxpayer. And it's pretty expensive. So for example, when Oklo has a meeting with the NRC, I mean, we're paying, and everyone else is the same, it's $317 per person per hour. So that ends up if you have a 2-hour meeting with 8 staff members. And so the bill is going to help offload that. It's going to change the framework so that industry doesn't have to pick up every dollar. But then this is where implementation is going to be important. Congress is going to have to make sure that they're covering that in the annual appropriations process so that the taxpayer has a little bit of skin in the game. And it's important, again, like I said, this is expensive, so it is important from us as we're working through budgets and figuring out the costs. But I think it's also really important from a value proposition standpoint. I mean, if we're talking about how we need reliable energy, abundant energy, clean energy, this is going to have an advantage for the nation and for the taxpayers. I think it's okay for them to be covering some of these costs to get these technologies that are going to provide that deployed. So that's one provision that I think will be helpful for us and probably for many others.
Yeah, I agree. I mean, I've long argued that should be the case. I mean, whether you like it or not, we've charged the Nuclear Regulatory Commission with permitting, licensing and permitting these things, and for public health and safety. And, those are, essentially, public goods. And so if they are, I think there's probably some conservatives who are like, oh, why is the taxpayer footing the bill for this? But this is a public good that actually should be borne by the taxpayer given the benefits that we are getting from it.
And this is unique, too, to the NRC.
For sure. Yeah, absolutely. Yeah. Katie, anything to add?
I will just add that we are tracking those items the NRC is working on very closely, both for the existing fleet as well as for the new plants. Where appropriate, we're providing input and suggestions on how they can do more and do better. And I'll throw back to one of the earlier panels on permitting. There's a lot of information in the Advance Act about how the NRC can streamline their permitting and what they really ought to be doing so that we can bring these technologies to market.
Yeah, and sticking on that, we have this new licensing framework, Part 53, and Marcie and Katie, and honestly, any of you guys can jump in here, but how is that process going? I know there's been some frustrations with it. Now it seems to be that there's some acceptance that it's actually on the right track now. Maybe that's being too optimistic. I'm not sure, given some of the companies that I talk to. But what do you see about Part 53, the new licensing framework? Are we on the right path, and what needs to change? And again, open-ended question. Feel free, anyone, to take it.
So I'll start by saying we're not waiting for Part 53. And Marcie and others can tell you exactly why and how they're not waiting. But the idea with Part 53 is that there should be a performance-based, technology-inclusive framework that the NRC can review an application from any reactor technology, not just the large light water reactors that they've become so familiar with over the last decades. There's been a lot of give and take, a lot of input from the public, from the commission themselves. I think we are on a better path forward with Part 53, but it still remains to be seen exactly how that finalizes and exactly how it works out. When we think about the time required for licensing, as I said, we can't wait, and no one is waiting. We have a couple of construction permits already issued for research and test reactors. We have a construction permit under review for the TerraPower Natrium facility in Wyoming. And then we have lots of others in pre-application, and they're all looking at the existing pathways and making them work so that we can get started.
Yeah, I'll chime in that Part 53 is just not on our radar. The pathway that we're pursuing is Part 52, which is a combined operating license. It's a little bit different than Part 50. So the pathway that we're using is a one-step process. And this is important for Oklo because our business model is a little bit different than what you see in traditional nuclear partnerships. We're going to build, own, and operate. So it's important for us to have that combined operating license since we're doing the construction and we're also doing the operation. So Part 52 is what we're pursuing. I mean, it's possible that when Part 53 comes out, this is something that we could look to for future designs. But right now, I mean, we've been in pre-application on a Part 52 pathway for multiple years now. So that's, I mean, we're full steam ahead there.
Yeah, it makes total sense. I know the ADVANCE Act was just signed into law, but I think from a policy perspective and from an industry perspective and a national lab perspective, you're always thinking about what's next. What else can we do from a public policy perspective to make an innovative industry more competitive in the marketplace? And so just running down the line, what do you think needs to happen either from a congressional standpoint for reforms within the Department of Energy or from a regulatory standpoint to continue to drive costs down and speed up efficiency, especially knowing that we have these huge load growths. We know we're going to need to build more energy developments, probably of all kinds. And so what can we do from the nuclear sector standpoint?
Well, I'll start with something that they shouldn't do, which is make this artificial distinction between new and existing clean resources. We've seen this battle playing out as part of the 45V hydrogen rule. There are others out there suggesting that data centers need to bring their own power plant when they site, which, I can't imagine the state of Michigan telling the auto manufacturers that they'd love to have that new production facility as soon as they go build a power plant. That's just not the way that economic development has worked in the U.S. And when it comes to AI, this is a national security race. We can't afford to delay data center deployment for 5, 6, 7 years while we build new generations. So I think this is a very dangerous artificial distinction that has implications for both existing clean and the new.
Marcie?
Yeah, the answer that I'll give is, I mean, ADVANCE Act is going to be so helpful once it's implemented. There really were numerous provisions in there that I think will be very helpful for those of us in the Part 52 pathway. But there still is a few more things that could happen. And kind of to piggyback off of David, we're thinking about rapid deployment. There was a provision in the ADVANCE Act to help with that, but I don't think it's enough. And the question is, what does a framework look like that will allow for rapid deployment without overburdening the agency and while still being able to maintain the safety that is so important as we are looking at these applications? I mean, it's almost as fast as the NRC can go won't be fast enough to meet the needs. I mean, this is all being driven by the data center needs. And again, with Oklo being small, I mean, if we have an announcement with a data center company, Equinix, for 500 megawatts, and so that's going to be 10 Oklo reactors at the 50 megawatt size if you want to do the math. And so that means that's 10 applications to the NRC, and that will scale over time and happen in phases as the data centers deploy in phases also, and that something that we can bring to the table in being able to phase up at a small size. But rapid deployment, and I don't know if we have the answer, but that's definitely a conversation that I think policymakers and industry and stakeholders need to be figuring out what that solution should look like. I know there's a few ideas out there, but that'll be important for the next go-round.
Great. Katie?
Yeah, I'll add that we have seen a lot of really good progress with things like the Inflation Reduction Act, recognizing the value of nuclear energy. We also need to help support folks get to those order books of firm commitments. So whether it's the firm commitment that enables you to reopen a closed facility, or whether it's the firm commitment that enables you to plan for a fleet of 10 or more of your reactor design, we need something to help bridge us from those first-of-a-kind results or costs, which we always know are going to be more expensive, to the nth of a kind, and share that risk and also reflect that value for the ratepayers, because we know that once we get to multiple of a kind, we will have that affordability.
Great. Brad, how about you?
Yeah, and I'm going to throw a lot of different things out there, so I apologize, because this is literally all I do every day for my job, is to think about these things. And there's absolutely more we need to do. I kind of wish I was still on the Hill so that we could have gotten a couple more of these things done. But building on what was said, on the regulatory side, on the advanced side, there's always more to do. I mean, we have to be careful not to. We just gave NRC a ton of work to do to figure out. Have to be careful not to give them too much more. They won't be able to do anything. But one of the main things in advance was changing their mission to include an efficiency. Unfortunately, Advance wasn't able to include some of the additional things that could help with that, like getting rid of uncontested mandatory hearings. If nobody has a problem with it, if nobody from the public wants to come to a meeting, well, why waste a bunch of time and effort and tax dollars planning and executing a meeting? They have the ACRS, the Advisory Committee for Reactor Safety. It's a bunch of old retired experts primarily that advise NRC and review every single application, whether they need to or not, basically duplicating a lot of the stuff that the staff's doing. So a lot of people are thinking, let's get rid of that. That's an unnecessary, time-consuming step. But it all boils down to doing things faster. If we're going to win the AI race, and we have to win the AI race because we can't afford to let China win it, we have to build reactors faster. We have to regulate efficiently and effectively and quickly. But as Katie mentioned, we also need cost certainty. The hyperscalers are willing to pay more, but they need to know how much they're going to pay. So addressing cost and schedules for the first of a kind is something we really still need to do work on. It's not a clear answer. A lot has been done in the IRA and the IIJA and others to address this. Some of those actually need to be fixed. People aren't going to want to hear that because it opens, it talks about opening these tax credits and stuff, but they're helpful to nuclear, but they need to be fixed to actually be useful. For example, changing the definition of energy communities so that actual energy communities that want to build nuclear can qualify. Changing the amortization of the investment tax credit. I know it's been done for storage, but not for nuclear to account for the long life cycle of nuclear. So there's a lot still on the table, not the least of which is the back end of the fuel cycle, whether it's recycling or waste. That was probably the big thing I was hoping to get done this year that we didn't. I know what we need to do. I just need to get the people that are still on the Hill to come together and agree with that. But there's a lot more work to do.
For sure. We're going to open it up to audience questions now. So if you have a question, identify yourself. And yeah, there's one in the back there.
Yeah, you mentioned the race with China. China is 15 years ahead of the US when it comes to nuclear deployment. And as a nuclear engineer who used to design reactors, I know that the nuclear problem is not a technology problem because we have proven that those reactors work. It is a deployment problem. So do you all believe that we are going to be able to beat China? And how?
I think we can, but the how is we have to build. We have to restart the existing reactors. We have to uprate the existing reactors. Me and my colleagues have done some analysis that we could put 50 gigawatts, or might need to put 50 gigawatts on the grid in the next decade. And it's possible once you look at building AP1000s, which a few years ago nobody was talking about. But we just put out a study that about 40 of the 50-ish existing sites in the U.S. could be home to another AP1000, building on the success of Vogel's 3 and 4, and leveraging existing licenses at many of those places. So we could actually get to that large-scale deployment in the near term. And I think we're still ahead on the technology front. Obviously, I'm biased to work for a DOE national lab, but the U.S. is the technology leader. China steals the technology and then implements it, right? I mean, we built AP1000s there, they copied it and then built their own. But in terms of the overall technology, with data centers, AI, we are still leading in those fronts and need to catch up on the energy supply to maintain the leadership.
Yeah, I think the key really is deployment, and we need to deploy here not only to ensure affordable, reliable power, but when you look internationally, China and Russia are building 100-year relationships around the globe by building nuclear plants overseas. And they've got a huge advantage as state actors. I know that the U.S. government has been looking at this both on the Hill with the Senate Intelligence Committee and Senators Warner and Rubio, the Department of Energy, and others, all looking at how to get things jump-started here so we can go sell overseas as well. So a lot of geopolitical implications here in addition to keeping the lights on back home.
Yeah, I just want to comment that it can't just be the nuclear industry fighting this fight. The downstream beneficiaries have to join us in this too, if we are going to be competitive and more competitive with China. And you are seeing that a little bit now with the data center. I mean, the deal with Constellation, I mean, that's a real deal. That's a household name, Microsoft. I mean, that's a great step forward, and we need more of that. And that goes to the order book that Katie mentioned. But beyond just the direct customers, I mean, there is a value chain for nuclear, like I mentioned earlier, the value proposition for the taxpayer. And so having more coalitions of groups, and I think that goes to a lot of you in this room who work for maybe different industries that represent maybe a unique blend of companies or member companies, and just how can there be more collaboration where it's not just the nuclear energy singing or the nuclear industry singing this song. Join us in the chorus.
I'm tone deaf, so I won't, but other people should.
Rehearsals are Thursday evenings.
Anything to add, Katie? No?
Nothing more.
Did you have a question here? Yeah. Sorry. She headed back first. That's okay. Go wherever you want. We have time for both.
We'll get you next.
Hi, yeah, so I just wanted to ask about, I know advanced reactors have different types of cooling, but I represent communities in particularly Southwest California, drought-prone and conventional, and a lot of advanced reactors do use water. So if those communities are interested in advanced reactors or conventional nuclear, how do we approach that issue of diverting water resources for cooling when they're already faced with drought and water supply issues as is? So
that's a great question. So while I'll say one of the keys to new nuclear designs is that they're working towards standardizing those designs, they are still standardizing with options. For example, you want to avoid needing fresh water for your cooling, then pick a particular design that does not need a lot of fresh water for their cooling. Perhaps they use molten salt for their coolant. Perhaps they use a high temperature gas for their coolant. So there are options there. There are also very creative options. One of our current reactors, the Palo Verde Nuclear Generating Station outside of Phoenix, Arizona, uses treated wastewater from the city of Phoenix. So we need to think holistically about all of our water resources and then work together to find the best solution for those communities.
And I'll just add a couple points. advanced reactors can actually help with water problems, as Katie mentioned. Even some of the light water reactor designs that use water for their coolant are developing dry cooling or non-water supercritical CO2 Brayton cycle processes for the steam, so you don't need water. But again, the ability for some of these reactors to produce super high temperature process heat actually makes water desalination very attractive in some cases. So, Palo Verde in Arizona is already doing it to provide their own needs. I think was it one of the reactors in California actually got approved to provide some water to the local community that they processed. The Middle East is looking at reactors for that very reason. So it actually it can help in that situation.
Great point. We have a question up front. Right here.
Oh, sorry.
Thank you. You had spoken about Vogtle and its success, but we also know it took forever to build and it was super, super expensive. I know there were certainly lessons learned. Can we deploy on budget and on time? Do we have the workforce? Do we have the infrastructure that we need to do that?
Yeah, I'll go ahead and start. Short answer is yes, but we need to start building now. With these large reactors, with a gigawatt scale reactor, you have tradecraft workforce that go project to project. So they've left the Vogtle project and are now on to their next project. So we can't immediately call them back. So one of the things we need to do to sustain that is have a schedule of build after build after build, so they can just go from one nuclear project to the next. But we will need to do more to get that. In terms of saying it's a success, yes, took a long time and cost a lot of money. But it's being estimated that I think that between Vogel's 3 and 4, which were largely built at the same time, with 3 being a little bit ahead of 4, there was, I believe, a 30% cost reduction in Unit 4 compared to Unit 3. Estimates from MIT and others suggest that the next AP1000 to be built will have over, I think it's a 54% cost savings. So there's significant learning that has happened. There is now an established workforce that knows how to do it. So once the next project, whether it's Vogtle 5 and 6 or wherever else starts, get that going and then keep it going, and that's how we'll actually realize it.
Yeah, I think DOE is in the middle of reissuing and updating their nuclear liftoff report, and I think it'll address a lot of those issues and include some new information. So I'd highly recommend that. I'd say on the private sector side, the other thing that we're doing on the workforce is that we've engaged the building trades and our other labor partners to assure that we've got a pipeline of ready workers. And so they've got phenomenal training facilities and organizations in place that are going to help make sure that we've got the workers we need moving forward.
Yeah, I was going to add to that we're doing a lot of work with the Center for Energy Workforce Development, and we have an action plan for developing that workforce of the future. And I'll say it really focuses across all job segments, across all opportunities, because we use more than just nuclear engineers, and we have a lot of the trades. We use more than just the trades. So it really is about opening up that talent pool and recognizing the 30-plus types of jobs that go into building a nuclear energy workforce and providing those resources so that folks can come join us.
Yeah, and I would just add, I think we really need to dig in and reduce those government-imposed costs that drive up the cost and timeline for these power plants, whether it's upgrading existing, building large light water reactors, or SMRs. Brad mentioned the mandatory uncontested hearings. That's one of laundry list of things we could change about the way we license and permit these reactors to really drive down the cost. I mean, there's regulations on what type of steel you can use that increases costs. The ALARA regulations is something that I've spent a lot of time working on that drives up costs on the industry and these are all costs for little to no environmental benefit or public health benefit. I think that's the other thing is it's the cost benefit situation of a lot of these policies are very skewed to the costs and not so much to the benefits.
Yeah, and if I could just add a little bit, because that reminded me of something I think that's really important and wanted to mention. It goes back to the broader permitting discussion. Eliminating unnecessarily activities and duplication. NEPA, for example. The NRC, to license anything, has to go through the whole NEPA process, which takes forever and costs a lot of money. DOE, with projects that they're executing now, whether they're advanced reactor demonstration projects, executing their authorities through the Nuclear Fuel Security Act to expand domestic fuel supply chains, they are delaying all of those projects by requiring DOE's own NEPA, which in effect is just going to duplicate NRC's because NRC is not going to just accept it. They're still going to do their own. So time, significant money. Another side, just quickly, is NRC makes applicants, and you would know this better than I do, but collecting data, temperature data, weather data, for example, they make the applicant collect their own data instead of relying on the government agency responsible for monitoring the weather. How does that make sense?
Yeah, that's a great point.
Thank you, Brad.
We are at time, but I want to give our panelists one more chance. If you guys have any closing thoughts, we can just run down the line here, or if not, that's okay too.
Thanks again for the opportunity. Always great partnership.
Absolutely.
Closing thoughts are, this is real, it's happening, and we're excited for the future.
Yeah, thank you so much, and please do feel free to connect with us offline, and we'd be happy to chat further.
Yeah, again, thank you. This is a great opportunity, great conversation. And again, I'm actually DC based, so please feel free to reach out anytime.
Awesome. Please join me in thanking our panelists.
Thanks, everyone. We'll now have a quick networking break, and we'll reconvene here in about 40 minutes. Thank you all.